Hello guys, this is the discussion of CEF round 1071 Dev 3. Let's start with the first question. Let's go on a full screen mode. Yeah. So the question is Blackslex and the password. And the time limit given is 1 second. So safely we can do 10 to the power 8 operation, as we know that in the 1 second we can do 10 to the power 8 operations, right? On a rough note. Yeah. Question states that Blackslex is designing a login system for GameDev, okay, and discovered that most users use weak passwords. To resolve this issue, he posted the following condition. Depending on two variables, key and x, alright, for all password, each password is a string s of length 10, satisfying these properties. S uses only the first key lowercase letters of the English alphabet. Okay, so we'll choose like yeah, E, B, C, D, up to K. Like, yeah, maximum K, like whatever it will be. And for every pair of indices, look at the condition carefully. For every pair of indices, EJ like I is lesser than J and lesser than equal to N, so that J minus I is divisible by X. All right. If this condition gets satisfied, then the letters Si and Sz need to be different. Okay. So we need to find the smallest integer n such that no valid string of length n exists. Alright. So I want to tell that find the smallest integer n such that no valid string of length n exists. Okay. So basically that if the valid string of maximum length n exists, then the smallest integer that no valid exists will be your n plus 1. Can we say that? Yeah, very nicely. And this is the input format given that the first line will be a single integer t line, basically 500, so that's a problem. And the first and only line of each test case, every test case have this two variable we need to take the input, that is k and x. And k is here 1 to 26 expected because 26 letters, so exactly representing the letters like A, B, C, E as 1, B as 2, C as 3, and Z 26, something like that. And this is the crazy part, like X is only 15. So you can think of like X is only 15 means I have to check for divisibility of 1 to 15. So this will also not bother. I can safely do here any operation like O of n square, n cube, if it needed like n to the power 4, because exactly, its complexity is not a problem for my way. Even we go by brute force. So we need to find that what is the minimum n that we look for. Exactly. So let's take this test case. This this is the second test case, and we'll try to analyze. Okay. So moving on, taking the second test case on the line, and let's go. Um, moving to the let's use 1 second. Yeah, the second test case is loaded. Okay, now we're going. Okay, so look at this. What we are looking for is this is your n that is given 3 and k is 2. Okay, now let's see what we can do for it. If n is 3 and k is 2, it means that, okay, let me put here only, like if n is 3 and k is 2, then it means what? Like it means that I have only 3 available letters, A, B, C, yeah, the initial 3, and I need to check for the divisibility of 1 and 2. Can I say that? Yeah, this is the one, it means that. Okay, now we'll keep it here for, let's do that. I have only 3 available letters and I will keep it for 1 and 2. Okay, and what is the condition, guys? There's a condition given that if I uh, minus j, or better to say that because j is greater than I, so j minus I is, if it is divisible by k, then a of I should not equal to aj. This is the condition here. Can we say that safely? Yeah. This is the condition here given. Okay. So let's keep this in mind. All right. So let's try to solve this one. Solve this test. Okay. Look at this. Um. Okay. So let's say that I'm using the. I'm taking that. Let's say. Okay. What we are looking for is, let's say that the group size is only two. Only two. Only two letter we are giving. Only two initial letter, the first pair we are looking for. Okay, so if you're looking for the first pair, then we can say that 1 and 2. Basically, this is the formation. Okay, 1 and 2. That's the, yeah, first pair, right? But that's not a condition. Like 1 and 2, if you take a difference of I and j, then it's not divisible by k, so we cannot choose that. It will not, like AI can be easy. So this is really not a border to us. Border is here, 1 and 3. Here you can see the difference. The I is 1 and j is 3. So if you take the j minus I mod k, it will give you that AI should not be equal to ASA. Exactly. So that is the first part. Similarly, if you see the 2 and 4, it will give you that AI should not be equal to ASA. Yeah, really. So A2 should not be equal to A4. Okay. Similarly, you can see the 3 and 5. That's the condition because it's working, isn't it? Similarly, we can have like 4 and 6. Exactly. Similarly, we can have like 6 and 8. Oh, sorry. 8. Oh my god. 8. Yeah. Guys, can you think more? Like, exactly. I missed the one. Let's put the 5 and 7 also. Okay. And 7 and 9. All right. Now look at this. You might think that I'm placing this 1, 3, 2, 4, 3, 5 continuously. Is it true? Like, really? I don't think so. Because look at this. The condition is saying that j minus I mod k, ai should not be equal to aj. Okay. So that's a twist, right? You cannot go infinite like this because if something like this will be there, if it's just given that exactly, it's not satisfying the j minus I mod k, because only this satisfies, but the j can vary from 1 to n, right? I can vary from 1 to n, right? So there's a problem that since I can vary from 1 to n, there is a problem. Okay, let's try to find it. Yeah, we can have like 1 and 5. What do you say? Exactly. 1 and 5, j minus I mod k. Yeah, so ai should not be equal to ASA. Exactly. That is a 1. Then similarly, we can have like 2 and 6 here. Exactly. Similarly, we can have like 3 and What do you say? 7 here, exactly. Similarly, we can have like 4 and 8, exactly. Then the 5 and basically 5 and 9, exactly. That's really not a concern. Okay. Similarly, I can have like if you get it more like 6 and 10, and most probably the 7 and 11 is right. Okay, that is the first part, right? Similarly, I can have a third group here. Let's write that also. Okay, so it keep on going like that. We are not concerned of that currently. We are just analyzing. Okay, so let's write a third group here. Okay, so let's write a little bit below here. Yeah, let's keep it here. Okay. Oh my gosh. Yeah, that's fine. 1 and 7. That's the one. Look at this. This is I and this is J. And look at this. J minus I mod K. AI should not be equal to AJ. Just satisfying. Look at this. This is 2 and 8. Similarly, right? Exactly. Look at this. There is a 3 and 9 part. It does work. It does work. Okay. Then we can have like 4 and 10 part. We can have like what do you say, like 5 and 11 part. Okay, we can have like 6 and 12 part. Yeah, and we can have like 7 and 13 part. Yeah, and we can make group like this. That's really not a concern. We can, let's place it here, or let's put it a little bit. Exactly, let's put it this also more constraint. Okay, it's fine, it's not a problem. So yeah, we can make group like this. Yeah, now let's try to put the characters for the first group. Look at this, observe this. Okay, let me do once. Yeah, for a character number 1, I don't have any constraint, right? I don't have any constraint, so I can safely put, let's say, the first character would be A, right? Yeah. Now, for character number 2, I also have not constraint, so I'll put just B, right? Yeah, that is also not a problem. But when I come to the character number 3 matches with 1 and 3, right? So character number 3 should not be equal to 1. So like the character 3, like basically the string element 3 should not be, yeah. So look at this. Why I'm wasting the second character here? That is the first point, right? If A could be 1, yeah, let's try to re-explain it, okay? Let me do once. For first character, I don't have any restriction, right? Yeah, clearly saying I can take any first character. So let's choose the first character as A. Okay, I have only 3 character, right? Remember that. Okay. For second character also, clearly like this is the starting one, so I don't have like restriction. And since I want the minimum n, so why should I waste the second character here, right? I will choose the second character also as it, isn't it? But now comes the twist. When I come the third character, look at this. I'm here as a third character. And in the third character, there is a restriction that the third character and the fourth character, look at this. The fourth. This pair is there. 1 and 3 pair is there. So look at this case. I'm telling this is not a problem. This is not a problem. This is third and fifth. Remove that. This is not a problem. I am only looking to this pair. I'm only looking to this pair. Okay. So since 1 and 3 are pair, means a of 1 should not equal to a3, isn't it? So I cannot put the third character of the string as a because it's equal to a1. So obviously I will choose the third character here as b. Similarly, you should, if you observe this one, 2 and 4, yeah, fourth character cannot be exactly rightly you're thinking. It cannot be B. It will be, right? Because of the A2 should not equal to A4. Now I move to the fifth character. It is bit twist. Okay, look at this twist here. Is that um yeah, look at this. Let's take a chain different color, else it's will be a problem. Okay, third and oh my gosh, it's good. Okay, here we are. Third and fifth restrictions. Okay, we will not look the lower one. We'll always look the lesser one for the restriction because this is the one we're deciding, right? That's what will be the next character. So look at the restriction here to the fifth character. The fifth character says that S1 should not equal to S5. Okay, and S3 should not equal to S5. So S1 is A, so I cannot place it as A here. S3 is B, I cannot put the fifth character as B. So what I left for? I will need a new character. And I have a available new character, that is C. So since I have a available new character C here, I will put the, exactly, you are rightly thinking. Since I have available character C here, the S5 would be C, isn't it? Yeah, so let's put it here for a while. Uh, Look at this. Like, let's put the S5 as C. Exactly. Do you get that? How we are getting? We are getting that. We are choosing. We are choosing the pairs that is lesser than 5. Okay. So this is the S3 and S5 representatives. That S3 and S5 will satisfying the condition J minus I mod K. So S3 should not be equal to S5. Similarly, 1 5 is satisfying. So S1 should not be equal to S5. That's why I cannot have the fifth character, basically S5, the fifth character of the string, as A because it's matched the S1. And I cannot have this character to be equal to B because it matched the S3. So I will need a new character. And what is the new character here? I have one available new character that is C, so I'll place it C here. Now, let's come to the fourth one. Okay, if you come to the fourth one, if you are prevalent amount up to this, then you can easily get that. Look at this. 4 and 6. Exactly. This is the one match. This is the another one. 2, 4. And that's only. Isn't it? That's only. Do you think that? Oh my gosh. Not really. Again, a girl match. There is a 2, 6 also. They're not getting. Oh, let's try to put more here. Like, let's come to the sixth character, guys. Okay. So look at this. This is a 4 6 I'm looking this side, the pairs with the 6 character and the 2 6. I'm getting the 2 pairs. It means that the S2 should not equal to S6, S4 should not equal to S6. Isn't it, guys? Exactly. So obviously, since S2 is A and S4 is B, S6 cannot be AB. I need a new character. That's why your S6 is also C. Do you get that? Now, let's come to the 7th character. So for that, I need to look for the pairs below it. So let's look for it. 5 and 7 here. Exactly. That's the one pair we find. Another pair we find it with 3 and 7. Okay. And another pair we find it at 1 and 7. That is a 1. So 3 pairs I have. Now look at this. S7 will not equal to S5. S7 will not equal to S3. And S7 will not equal to S1. Now, S1 is A, so S7 cannot be equal to A. S3 is B, so S7 cannot be equal to B. And S5 is C, sorry here, S5 is C, so S7 cannot equal to C. Do I have any available character? No. So this could be your final string, maximum. Exactly. This is your final string. Okay. I cannot have C here because maximum length string, this is the one. So minimum possible length string here would be, you are right. Since the length of this is 6, minimum possible length of a string not possible is 7. Do you get that? Exactly. Now, this is about here. What about the general one? So if I do some observation here, then I will get certain things. Since this is not a possible pair, we should not need to look for it. Isn't it? Yeah. This is also not. So I'm discarding it. I'm discussing it. I'm also discarding it. I'm just choosing the feasible reason. So this is the feasible reason. Do you get that? Exactly. This is the feasible reason we have. So in this feasible reason, if you observe, there is a few things to observe here. Okay, let's observe. Oh, let's observe certain bit of things and then we'll try to explain you. Okay. Let's observe. Okay. Fine. Look at this. Um, for given value, like for given k2, I will able to form only 2 groups. And that is quite viable, isn't it? Because look at this. When you divide the k here and 3 with 2, you will have possibly 2 remainders, the 0 and 1, right? So the group will be your, if I try to write, then maximum number of group is your part on my screen, little bit dim, is the number of remainders, isn't it? Number of remainders is the maximum number of group possible. Okay, yeah. So here the 2 remainders are possible. We are able to form the 2 groups. Okay, very nice. Now, if you do the second observation here, That is a very interesting observation, and if you do that, you get the answer in just 1 sec. Oh my gosh, let's try to show you how that implementation, basically observation, not implementation, will be done. That I'm not able to observe in the contest. This 6. Do you get it? The maximum value we are going, maximum character we are going is 6. Basically, the maximum, I'm telling that I'm going the maximum character index. Basically, this is not a maximum character index. I have a possibly 6 characters in the string. Means I'm going from S1 to S6. So my string length would be 6, isn't it? And it's just not a random number. If you just observe it, I have a n as 3 and k as 2. So I have a possible string length is of 6, basically n into k. So if you do the second observation, your work is done. That maximum possible length of string, sorry, is your n into k. So in general, if you talk minimum impossible length of a string will be minimum impossible length of string would be very simple, that is n into k plus 1, isn't it? Exactly, and that's what is asked. So that is our answer. That's it. Let's just go for the implementation part of it. Very simple it is. um, this is the question, and you see this is 7. And let me tell you my implementation. Like, what I does is that I'm a little bit idiot. That's why I'm not able to observe in the contest that n into k plus 1 will be the impossible. Just next, like n into k is the maximum length, so maximum impossible length will be n into k plus 1. And because of that, I done a dirty implementation of it. Okay, so what it does is that I have used the map, and what it is storing is that the key is storing the group number, and the value, that is a set, is storing characters in the group. Okay, and this is the possible initialization of n. That's it. So what I'm doing is that I'm iterating from the every possible value of n. Okay, so when I'm at I equal to 0, the remainder would be 0. Let's say the x is 2 for this test case, as we choose an early. So for this test case, if I choose C, then I will be 2. That's a 1. Exactly. Then it will, then I would be like, it will run for I equal to 0, remainder will be 0, it go on in the group 0. I equal to 1, remainder would be 1 mod 2, that is equal to 1, so it will go in group 1. I equal to 2, remainder 2 mod 2, 0, go in group 2. I equal to 3, 3 mod 2 equal to 1, it will go in group 1. So basically, for if you check for a possible x, it will filter the group, that which group it is going. So obviously we are clearly observing that there are 2 groups possible only for 2. Yeah, as we filtered out, because there are 2 possible remainders, right? Now what flag is doing that, it is utilized to find the other possible member. Like for 7 we check, we do not have any other pair. Basically for I7, like for 7 there is no possible I, right? As we observe. Yeah, so that's what it's doing. For a possible I, I'm checking what pairs is as we found out that there could be like 0 to k, isn't it? So I cannot have more pairs like exactly as we observe there 0 to k is the implication, means I cannot have k that is basically I was telling that the second part I cannot go beyond k because I have only 3 characters limited. Okay, so since I have only k characters given, I will only go for k, else I would have gone safely to all the 26 characters. But as per the input, since I have given with the k characters, I can maximum go to k characters, isn't it? Now, group remainder or find, basically what we are looking at in the particular group, I'm finding the j, basically the other pair. If you take a pair I and j, sj minus si, remember that? Yeah, that is a 1. So we are finding the j. If it's not there, then we will insert and we'll get a pair and flag 1 break. You get it? It means that for a particular value I have a pair. For a particular j, there exists a pair. Okay, but what I am looking for, the one where the flag is unchanged. So as we see in this test case that for 7 I don't have any possible I, so I will not find any pair, so the flag will remain unchanged, isn't it? Yeah, it will be 0 and we'll break it and we get the value of n. But you don't need to do this. This is a dirty implementation of me. Let's try to re-implement. Okay, so I have the inputs k and x, and very simple, like you do not have to worry because we just find out that the minimum possible length of group will be x into k plus 1, and that should be our answer only. We don't need to do that much of implementation. If we just observe this single one line, and if I just push this, let's go, let's push it here. It's most probably the exactly it's going on. Exactly, it's I see. Let me check. I just putting there like let's go, let's go. Exactly, easy. So that's a good answer of it. Guys, let's start with the second question. Let's go on a full screen mode. Yeah. So the question is Blackslex in souring. And here the time limit given is 2 seconds. So obviously we can do the 2 into 10 to the power 8 operation safely. Okay. Now, after this IMO medalist friend soured for 2 hours, okay, so that it does not have to sour this again this week. Oh my god. Like you're souring for 2 hours and then not souring entire week. Crazy people, crazy IMO ones. Good to IMO ones. I have also friend in IMO. one of the medalists. So good, like connection will be good though. Like I can really relate to it. Blackslex will be late for the class. Okay. In order to get to class, Blackslex must take the crowded elevator to many floors in a certain order. Okay. Because he's a hacker, he can skip visiting up to one floor. All right. So means he can skip visiting up to one floor, means he can skip either zero floor, we can say, or we can say that one floor maximum he can skip is one floor. Okay, without the other people knowing. All right, hacker, let's move on. His time taken is the sum of absolute difference between the consecutive floor. Okay, numbers, yeah. So whatever will be the floor number, the time taken will be the difference of it. Fine. I need to find the minimum time taken, given that he can skip up to one floor. That I already told that he can skip maximum one floor. I have to find the minimum time taken. Okay. More formally, we are given with the array a, a1, a2, an of an integer, and I can choose up to one index k, 1 to n, to erase such that the sum is this. Summation of I equal to 1 n minus 2. Okay. So if you really want to read this more carefully, then you will see that I'm given with the array of an integer, and I can choose up to one index to erase. Means, moreover, I have to like erase one index. Okay, yeah, that is the one. Like I equal to 1 to n minus 2. So basically, in my final array, I want the n minus 2 elements. Okay, do you get that? Means anyway we are going to erase one element from this array. And the condition is that this I need to minimize, where b is this a1 ak minus 1 ak plus 1 an is the array. After erasing element ak, I need to report the minimum sum of it. And what can I think of as that I'm given with the array, I can choose this, and I'm supposed to erase one element. All right. So look at this. And let's first read the input format. So yeah, this is the number of test cases one. End of each test case we have basically given with the size of array and the array elements. And this array elements, I need to remove one. Basically, I can say that I need to skip one. Can I say that? Exactly, guys. Means if you try to think it, let's say, yeah, I have to skip one anyway. Okay. And I have to take the minimum time taken. All right. So because um I have to skip one, and I will say that this is somewhere based on like skip on take. Is it like a DP based? So look at this. The n constraint is going to 10 to the power 5. But the better part is that, okay, I will say that the better part is I'm not bounded to choose like, yeah, maximum time what can be. Like, I will say that here I'm bounded to skip maximum one floor. So there should be two cases arise that I will skip either zero floor or I will skip either one floor. Okay, so somewhere like, yeah, you're right. I have to find the minimum sum. You are right. It's somewhere, what do you say? It's somewhere based on DP, right? Can we say that? If you've seen the prog to question of AdCoder, it's actually based on this only. Like, yeah, it's just a simple version of prog 2, I would say. Isn't it? Let's try to explain you. Let's go. Okay. Let's go on a full screen mode. Yeah. So the first thing comes in DB is what could be the state here. Okay. So let's think of it. It is DB. Can I say this I? Oh my gosh. Z. Yeah. Oh fuck. What I'm doing? This is the minimum total time. Okay. To visit floor AI by skipping total J floor. Total J floor. Can I say that? Exactly. I forget to mention you that in the array, the AFI is basically the floor number. Okay, given. That's why we are taking the absolute difference, that is basically time taken to visit the floor, as it given in the question. If you read the, yeah, the time taken is the sum of absolute difference between the consecutive floor number. So basically your EFI is nothing but the floor number. That's what I'm telling. That minimum total time to visit floor AI by skipping total J floor. This will be the DP part. This is the state here. So now, if this is the state, then comes the question. Like, okay, so I will say that J, yeah. What could be the J here? 0 and 1 only? Isn't it? Because I have to skip, like, I can skip maximum one floor, isn't it? I can skip maximum one floor. So two conditions will be possible. Either I have skipped 0 floor, yeah, and either I have skipped either one floor. So if I thought of the transition relation here, then what it could be? Let's think of it. What could be the transition relation? Okay, let's try. Okay, so case one, basically we don't skip. 0 skip. We don't skip, right? In this case, if you don't skip any floor, then the transition could be dpi, yeah, minimum time, basically say, is your the previous state, like just before, yeah, dpi minus 1 and j, and more appropriately I would say that it should be 0, isn't it? Because we don't skip it, so j is 0, plus, as given, the time taken, the new time taken to visit the floor AI would be absolute difference of A of I minus A of I minus 1. Do you get that? That's the first case. If this is the transition relation in the first case, If I have zero skip means I have not skipped any floor. All right. Now, in the case two part, okay, I have skipped one floor. So look at this. Now I have skipped one floor. So there can be two sub cases. Either I have skipped one floor very early, means not the neighbor one. Initially only or somewhere in between I have skipped one floor, but the previous floor I have not skipped. Basically, I have not skipped the neighboring floor. Can we say that? Yeah. So there could possibility is that there are two subcases here possible. Subcase A, I would say, that is, I have skipped the earlier floor. Earlier floor, not neighbor skip. So if I have not skipped the neighbor, what could be the transition relation? Let's try to think. Let's a little bit resize it. It's going a little bit larger. So yeah, now it's fine. So the transition relation in this case would be your DPI. My gosh, maximum I will taking it as 1. Yeah, because I'm skipping the one floor, so J will be 1, more appropriate. Will be your DP, I would say, not neighbor skip. All right, means neighbor is there. So I will take the neighbor state, DPI minus 1. And obviously the neighbor, up to neighbor, I already have skipped one floor. So that's the J. And obviously the absolute difference, the overall next time from neighbor to the current floor, the ith floor, basically I minus 1 to ith floor, what is the time taken? That is A of I. This is the difference between the floor number as it given. Okay. The subcase B could be that, okay, I have skipped the neighbor. Earlier we don't have any skip, but I have skipped the neighbor. So neighbor gets skipped. Can we say that? Never get skipped. So if you skip the neighbor, then the current state would be, okay, is your DP. Since now the neighbor is skipped, we don't have a neighbor here. We have previous one before neighbor. Means, oh my gosh, what I have done this. Let's write it correctly. I don't know what's happening today. Like, yeah. So since I have skipped the neighbor path, I am looking for the previous one of this. What is the previous one of this? Means ith floor is there. I minus 1 floor I have skipped. So before that will be I minus 2 floor. That's it. Okay. I minus 2 floor will be there. All right. And at that moment, I don't have skip. I don't have skip the any floor, right? So what is the skip count there? 0. Very nice. And what is the time taken to go from I minus 2 floor to ith floor? That's the absolute difference of the floor numbers. Very nice, as we know that. Okay, yeah, that's the one we look for. So this is about the DP part, and this is about the transition relation part, right? Now, let's try to think of what could be the base case here. Okay, because in the DP we know the base case is critical. So let's try to think of, because we covered the transition relation part, now we can think of as the base case. Okay. So we'll say that in the base case, yeah, if I have to go by like tabulation approach, or you say the like yeah, what I think of it. Yeah, first. Yeah. So let's say, okay. So we are thinking of the base case here. And if I go by the tabulation approach, that is your bottom up approach, then the possible base case could be that I am at the zeroth floor, means I have not visited any floor, and I'm not skipped also. So obviously my DP will be zero, isn't it? Can I say that? Exactly. Okay. Another possibility is that in the zero skip only, I'm at the zeroth floor and I have skipped a one. Yeah. So the base case could be not possible, right? So since I need to find the maximum, basically not, I need to find the minimum total time to visit. So I will put it a very large number, let's say infinite. Why so? Because when we take the minimum in the state finding, it will not affect our answer, because basically minimum of something and infinite will come out as something, isn't it? Yeah. Okay. Let's see more. Like this is the base case one. Let's little bit. It's bigger, right? Let's try to small it one. Exactly. And put it there. Okay. This is the one part. Let's try to fill more. This is the case. Let's talk about the base case in case two. So that would be your, you have skipped one floor. Yeah. You are at the floor one and you have skipped one floor. So base case will be zero. Means you are starting with the floor one. The first skip already happened at the zero floor, so base case will be zero. All right. And the second could be that we are at this floor one and I don't have a skip any floor. So the base case would be your absolute of a1 minus a0. Um, Basically, we are at the floor a1 and we don't have a skip any floor. So what is the time taken? That is this one. Do you get that? So this is the case part. Like this is entire DP part. Now, obviously, we know that we have a two approach, like tabulation approach, the bottom up one, and the memoization approach, the top down approach. But due to functional overhead, we prefer tabulation one. So I have done the implementation in the contest by tabulation approach only. Let me show you that for a while. Okay. So this is the implementation part. Better that I would redo it in front of you. Better that I will redo it so that you will get the better idea that how it's working. Okay. So let's go. What a question telling that I have an input format given, the size of array, and the second line is integers. Okay. So we are doing that. We're going on a full screen mode, guys. Let's go. This is the end. All right. And for the back. Yeah, yeah. All right. Okay. So we taken the input. Now, if you try to see, we have taken the input. Let's clear this one. Yeah. So let's say, yeah, we have taken the input here. Okay. Now as we discuss, the state could be, so we have a table for tabulation 1 that's storing the 2D grid, and basically dp I. The size of the grid would be like n, because we have total n floor, and I need to like do two cases arise that where I can skip. So we have like whack two cases basically. Either I can skip um, 0 floor or 1 floor. So for that, the 2, and initially I'm initializing to a larger number for the cases where it doesn't have to, like it doesn't exist. The cases which is not possible, that's why we are giving the initialization to the larger number. The reason behind that, I already told you that I need to find the minimum total time, right? So if I take the minimum of a larger number and a certain viable state that exists, the viable state will be answered. So it will not affect our overall calculation. That's why we take the larger number. Okay, good, good. Now let's write the base cases first. Let's fill the base cases in the table. Okay, so basically the DP, what do we say? We are filling the first case in the zero skip, right? So we are at the floor A0 and we have not skipped any floor. So basically we are at the starting floor. So I don't need to have any time. Like we are at the starting floor only. So we don't require any time. That's why 0, isn't it? Then DP 0, 1. We are at the floor A0 and we are telling that we have skipped one floor. That's really not possible, right? So we'll fill as it is, although it already filled, but we still filled the larger number so that it will not affect our answer. Okay. Another could be, we are at the floor AI and we have skipped one floor. So the answer would be 0. Like you are at this floor AI and you already skipped one. Means you are at the floor A1, considering the 0 best. You are at the floor A1 and you have skipped one floor. So the starting floor will be 1, A1 basically. So what is the time taken? Like you have not moved anywhere. So time taken will be 0. That is the one we look for. Okay. Similarly, uh, we are at this floor A1 only, and I don't have skipped any floor. So the time taken will be your, as given, absolute of the floor numbers, A of 1 minus A of 0. Very nice. Okay. Now for others, we'll follow the transition relation. We'll follow the transition relation. Okay. So So let's iterate about the other floors. So we are, since we already filled the two floors, the other floor will be A22 A of n minus 1, because we are taking the 0 base index. Okay. So the case A, we do not have case 1 0 skip. If we have a 0 skip, then the DPI, as we discussed, is simply I0, 0 skip will be simply the previous state, that is dpi, oh my gosh, dpi minus 1, 0, and plus absolute of a of, what do you say, I, the basically the difference, floor number difference. Yeah, that is the time taken, the new time taken, isn't it? Oh my gosh, a of I minus 1. Yeah, that is the one we'll look for. So this is about the zero skip. Now the case 2 could be that I have one skip. I have one skip, and in that the subcases, two subcases. Subcase 1 will be that uh, I have not skipped the basically I I'm the subcase one. I not skipped the neighbor. So never no skip. Never no skip. I have not skipped the neighbor. In that case, the possible state would be your DP never to never we have skipped one, yeah, and absolute of the difference. Obviously, the more like the total there from a of I to a of I minus one. Exactly. And the second get possible that never we have skipped. So if you have skipped the never part, we'll get earlier we discussed we are at the I minus 2 floor because never is not there. At that time I have like no skip, so 0, and then absolute of a of I, yes, the difference from I minus 2 floor to a of I. This is the time taken, this is the minimum time taken. That would be the answer. But finally, since I need the minimum of total time, so for this possible state, I will take the minimum of both the cases, sub cases. Exactly. No skip and the negative skip. Like never is not skipped. Do you get that? Now, this is about the filling. We filled our DP table. Now, what I need, I have total n minus 2. As we discussed, question is telling that where the question is, yeah, here. You can choose up to one index k to erase so that the sum is this, I equal to 1 to n minus 2. So is minimized. So anyway, I have to erase one element. So it will contain the two element. All right. So what I'm telling that since basically I have to erase total n elements, I have to erase the one element. So in the final array, this relation, we have, yeah, in the minimum total time, I have erased the one element. So I'm left out with n minus one element, right? So what could be the answer here? So there are two possibilities, like either we have erased like what I can say. I am left out with only n minus one element, yeah, in the array, and I have not skipped any. In that case also I have erased one, isn't it? So this is the one possibility that I have taken the n minus one element of the array. So obviously we are taking the zero base, that's why n minus 2. And I have not skipped any floor. Then in the final array, I have actually deleted one, isn't it? And another possibility could be that I have skipped one floor and taken all. So all the arrays will be covered. So that's the one. Like I have skipped one floor in between. So I will go to all the array elements. And in that case, this would be the answer. So basically the minimum of both since needed, that would be our possible answer. Let's try to run it. Oh, there's something error. Oh, negative. No, skip. Okay, let's try. Yeah, as expected. So this would be my approach in the contest. Now, if you are thinking that how can I implement using the memoization approach, so we'll try to convert this in the memoization approach. Okay, because I done by tabulation, I prefer tabulation because tabulation is more faster, I would say, and it doesn't require like what you can say the functional overload. Like here, the recursive call doesn't happen, so the overall space complexity get lesser. Okay, because of the less like here, no recursion call will be there, so the functional overload will be lesser. Basically, the space complexity is lesser, so we prefer the tabulation approach. But let's try to implement by the memoization approach. And let's say, so for that, I need to do the certain bit of changes here. So let's write the memoization table part. So let's say I don't need this one. I will use it as a memo tab. So let's go. All right, vector vac, yeah, memo table. And now since I'm taking the n, I need to put the n globally, and we'll take the input in every single case. So n, and we have a vac and 2 1 80. Basically same thing like we are taking the memoization table. Now for the recursion call, I will do this dp, and we will have basically the floor number, not floor number. You are at the index, so we are at index I dx, current index. So it will represent the floor number, basically float index. Like if you have floor ai, the index will be idx. So this is the current floor that I'm looking for. More prefer I will write it as I, because if I write it as idx, it will be little bit lengthy in the writing. Yeah, that is the one we look for. And second is the count. What is this count? This is the count of how many floor I skipped. Okay, and as I'm looking that, I need to pass this vector also, because I need the values of this in the base cases and other calculation. So I am doing that. And all right, don't forget to pass the vector by reference, else what do you say, you'll get daily because of the lot of copying of it. Okay, like yeah, you're not able to update the vector, so a lot of copy will be created because of a memoization table. We will get the daily, so that's bad, right? Exactly. Okay, I already taken this one. All right, so let's try to fill this. We are here at the base cases. Okay, so in the memo table, what can be the base cases? That could be exactly for the zero case. Like if you try to think then this way, if I is equal to 0 and count is equal to 0. Okay, basically this base case, what should we do? We'll just do the return 0, isn't it? Yeah, we are at the 0th floor, means we are at the starting floor. We have not skipped one. The time taken will be 0. That is the one we look for. Similarly, we are here, I is equal to 1, and you have skipped 1. So still you are at the starting array, so you don't require any time. Another base case could be that I'm at the I equal to 1, and I have skipped, I have not skipped any floor, so absolutely I'm here, uh, a of 1 minus a of 0. That's the time taken. Another base case could be like I am at floor 0, and I'm telling that I've skipped 1. This is the same case, that's impossible one. So what should we do? Like, well, just written 118, isn't it? Exactly. That is the one. We're done. So we'll fill the base cases. There is another base case that is the path of memoization we know. So that is a memoization base case that if the previous state is known, okay, basically if memo I count is not equal to 118 means it is known, it exists. We'll just return uh, dp I count, isn't it? Yeah, that's the one. Oh, yeah, you get that? Okay. For others, simple transition relation will follow. So there are two possibility here now. If I will be 0, okay. If I will be 0 means, not I basically, if count will be 0 means I have 0 skip. In that case, the your memo, what do you say, like I, and exactly, this is count that is 0, more preferably that is 0, is your the previous state we calculated. This is, we are calling the recursion call because the previous state is not known. So dpi minus 1 exactly, and the count will be 0, and we are passing the vector. And for the ith floor, I minus 1 floor to ith floor, what is the time taken to reach? E of I minus A of I minus 1. Okay, if it is the count as 0, right? So we'll just return this one, memo I 0. That's it. What if the another possibility here is that count is 1? In that we have two sub cases. As we said, we have skipped the never. If you skip the never, then the I minus 2 exactly, and count that time will be 0. Yes, and that's it. Like absolute of a of I minus of a of I minus 2 to reach the I minus 2 floor to a of I floor. Another case would be that no neighbor is skipped. Like I've not skipped the neighbor here. So if you not skip the neighbor, then the previous case will be I minus 1. This is the previous state known, and at that time we have already skipped 1. So that's a 1, and a absolute of a of I minus of a of I minus 1. So what could be the memo I1? That is this state, current state, is the minimum of the both the cases. Yeah, you have skipped the neighbor, and I have not skipped the neighbor. Both the cases, this is the minimum part. So this is the memoization calculation table, memoization function that will be utilized to calculate the states by memoization approach. Okay, now, so let's just comment this out, and yeah, all right. Now, since there are multiple um, test cases here, I want to change this always memo table. That's why we'll do the resizing of it. Okay, and always we have to get taking the new n, and yeah, we are giving the vector to 118. So we are always resizing it exactly. Now this thing here, the final answer would be that it's not a state one because the state is not known. So the answer would be here that I need to calculate the state. So I'll just do the recursion call. That's your minimum of dp. What do you say? Like here n minus 2, 0, and a, and this is dp, n minus 1, 1, and a. That's it. Exactly. Let's try to run. Oh, what happening? Am I getting TLE here? Taking a lot? Oh, yeah. Why TLE? Why TLE? If you try to think from here, that's not a problem. This is also not a problem. Like, oh, here, dp. Since the previous state is known, your idiot is recalculating it. Why I'm doing that? The previous state is known. Why to waste the recursion call there? Let's try to see. Will it run? Uh, okay, it giving certain warning that control reaches the end of non-void function w written type 641. Oh my gosh, I have not even written here. Okay, who will give the return here? That is another reason. That is the another reason. That is the another reason that I'm getting TLA. Ah, but I'm getting the wrong answer. But why? Why I'm getting the wrong answer? Oh, is it the resizing don't work? Let's put a scene there because the resizing might be some extra is left, so that's why I'm getting the wrong answer in this case. Let's put that sign. Yeah, it worked. A sign does work. So that's the answer, guys. That's it. Okay, guys, starting with the third question here. Let's go on a full screen mode. So the question is Blackslex and the number theory. Here the time limit is 2 seconds per test case. So obviously we can do 2 into 10 to the power 8 operation safely. Now, Blackslex worked too hard and started dreaming about numbers. Okay, looks like some crazy mathematician is here. Solve the following task from his dream. Okay, he's solving the task from his dreams. Okay, let's go on. You're given an array a1, a2, an. Okay, and in one operation, I can choose an index I lying between 1 to n and an integer x, which is at least k, alright. And I will set the AI as AI mod x. Okay. Basically, what I'm doing that, I'm one operation, I can choose any index from the array and I will choose an integer x which is greater than k, and I will put the AI as AI mod x. Alright. That's the one we know definition of this is limit. That's not our function. Our goal is to make all element of array identical. Okay. Among all positive integer k, determine the maximum k for which there exists finite sequence of above operation that make all array element equal. Okay. So what is our goal is to make all the array elements equal, right? By doing this operation, it there is no limit on the operation number, on like count. I can do infinite number, or basically I don't yeah, like I can choose any index and I can set. That is the problem. Like I have no limitation on how many times I'm doing this operation. Okay, and among all positive integer k, I need to determine the maximum k. Okay, for which there exists a finite sequence of above operation. All right, so I need to determine the maximum k for which there exists a, okay, so finite sequence of above operation that make all other element equal. Fine. So basically I need to maximize the k such that by performing this operation all the element of array would equal to each other, like they become same. Yeah, that's the one that is saying. And this is the input format. They're given n, and basically we're taking the array as an input, and output we just have to maximize the k. Okay, now what can I thought of here? Let's try to think. So what can I thought of here? Let me explain you a bit. Okay, let's take this here. Yeah, so what the question is saying that, yeah, let's go. So as per I understand, the question is telling me choose any element in the array and I can perform this operation. Yeah, mod of x. Okay, any number of time on this index, and where the x is lesser than equal to k. All right, that is the point. I can choose the index and I can perform this operation where x is lesser than equal to certain value k. That is the point here. And finally I need to make the all the element of array equal. Okay, now there is a point here. What is the thing to observe? That when you are performing the operation ai mod x, you are getting the value as the remainders of x. So the x could be like, when you perform this operation, I will say that ai should always be lesser than equal to x after performing this operation. Can I say that? Because we always get the value that is the remainder of x. Yeah, very nice. That is the point. Now I, okay, here, sorry, the condition is that x should always be greater than equal to k. Okay, that is the condition here. Yeah, now I can, yeah, so basically I can choose any k here, and that is exactly, basically that is the possible range. Okay, so I need to maximize the value of k. Obviously, that's what I need to do here. Okay, what I can observe here is that the, let's find the range of x. For that we can get the range of k. That is not a concern. Okay, so what I'm thinking that first we prove that ai should always be lesser than equal to x. Means another thing we can observe that elements should always decrease. Okay, element should always decrease or remain same. Yeah, in a certain situation, if they are lesser than, let's put it down a little bit. Let's put it here. This is fine. That's what we get. That element should always decrease or it remains same. That is the point. Okay, guys. We'll try to think more. Now, I need to choose x here. Okay. So, what could be the possible range of x? What could be the possible range of x here? I don't know. Like, do you have any idea that, yeah, because I don't know the value of x, right? X could be 0, x could be 1, x could be 2, but my thing is that not the value of x. My thing is that choose the x such that all the elements become equal after performing this operation, isn't it? That is my concern. So obviously x could be 0, but let's say that I choose the x as the a0. Okay, so if I choose the x as a0, what will happen? Okay, so before that, I want to think more that, let's say the array is sorted, so that we're choosing the minimum value, we don't have to concern much, and the complexity is like the n is 10 is the power 5, so even the array is not sorted, I can sort it in the n log n. That is the point. So we can safely say that the array is sorted. So if the array is sorted, then I can say that if the x is a0, means I'm choosing the minimum value of array, then the this value, when you perform the a0 mod x, okay, it will become 0, isn't it? Yeah, it is. It will become 0. But when you choose the AI mod x, or let's say any general, yeah, any general AI mod x, its value will be lesser than equal to x. It is. It is. Right. So one idea I'm getting that the x will be any value from 0 to a0 from this case. Yeah. Now, if I choose the x is a1, okay, then the a1 mod x should equal to 0, obviously. A0 mod x is equal to a0 because it's lesser than a1. And for others, mod x will get lesser than equal to x. So I'm getting the two values here. Look at this. Yeah, I need to have two values because I don't know that 0 and a0 going to be same, right? So I cannot choose this value of a1 as x because I have to make all the values of array to be same. So I cannot say that the x should be a1 because if x is a1, a0 not necessary should be 0. So this case will be discarded. This is discarded. Yeah, discard. But if you look at the first case, then I see that a0 will be 0 and other will be lesser than equal to x. So it can be possible that the other value would be 0, right? Exactly. And if I choose any value, let's say, yeah, if I choose any value, okay, let's say lesser than a0, then the a0 mod x, I don't know, like it has been lesser than equal to x, not even a0 mod x lesser than equal to x, but more appropriately I will say that all the values of array should be lesser than equal to x, isn't it? Now do you get the idea? Like, yeah, so what could be the range of x I can choose from this? From safely I can say that the range of x should be any value from 0 to let's put it above its bit. become crunchy. Like let's put it here. Okay. So range of x would be any value between x equal to a0 to 0 to a0 basically. Why? A0 because there is a one possibility we are getting if all the values here is 0. Our, yeah, if I choose like I would say that if all the array element is equal, choosing the A0 will work as x, isn't it? So this, we are getting that this is the range of x, or this would be the range of k also. Now our answer will be lie on this range. Like I got the idea that a range of x would be always 0 to a0. Now if I look the constraint part, let's look at the constraint part. What is the a0? So ai is 1 in 9, right? So I cannot take brute forcefully and check like, yeah, because it will go up to like 10 is to the power 9 and 10 is to the power 5, 10 is to the power 14 operations. So I cannot check, right? Brute forcefully I cannot check. So what I should do to get the value? That's our concern. Like, oh, let's put it down. Like, okay, what should I do? Let's try to think more. Okay, so I would say that this is not a range of x, but x minimum. Can I say that? Or your k. Yeah, that is the one. So we conclude that x minimum or k will lie between 0 to a0, right? Now, what I need to find here is that, let's try. Oh my gosh. Let's choose some color here. Let's change this to yellow. Okay. So we'll try to prove certain bit of things here. That observe that I need to find the, oh, it's not thirsty. Okay. So we'll choose blue. Okay. All right. So until now, I have concluded that the range of x should be lie between 0 to a0. Yeah, x minimum or k will be lying between 0 to a0. So what I need to find, I need to maximize the k. Okay. Or basically, I need to maximize the minimum of k. Oh, I'm sorry, minimum of x. Do I getting some idea of what? Maximize the minimum of x. Exactly. And is it a monotonic function? Is it a monotonic function? Look at this. If the k will be your, let's say, certain value like 50, and it is lesser than a0, let's say the a0 is 100, then the 50 will be valid, 51 will be valid, 52 will be valid. So it is a monotonic function. Something like true, false, isn't it? Because after, let's say, as I said, that k is 50, then for 50 it is true, 51 it is true, a0 is 100, upper limit is 100. So up to 100 it is true, after that it will become false. It cannot be the possible range. So it is the monotonic function, obviously. So we can safely apply the binary search and answer here, isn't it? Yes, it is. And what could be the range of the search space? So if we talk about the lower range, it could be obviously 0. The k could be 0. That's not our problem. Like that is not our problem. What could be the highest range? So if I look for the highest range, that is a0. And what could be the maximum a0? Let's take the question here. It is 1 in 9, isn't it? Yeah. So that is the one. The high would be 1 in 9. And let's add some buffer so that it's not a problem. Okay. So that is a point we get, that we come to the conclusion that it is a binary search question. Binary search and answer question that is safely applicable here. We have got the range of search space. Now, the next point is that what could be the check function for this? So that is our problem. And if I come to this, then let's try to visualize that what could be our check function here. Okay, so I need to check, let's say, a certain value. Okay, and basically, I don't know, like I am given with the array, right? Yeah. And what is this value? What is this value going to do? What is this value going to do? It will check. It would be possibly the mid. Yeah, it will be the possibly the mid. So basically, it would be your mid, right? Can I say that? Possible mid. Exactly. One of the mid value of the binary search lying in the range in the search space, low and high, obviously. And if mid, what does it will check? Like let's try to tell you more. That I need to make the all the arrays equal. Like I need to make the all the array element equal. So can I say that finally they will equal to a particular value, like a particular target value, isn't it? Let's say the target is that they become finally equal to this, isn't it? Yeah, they become finally equal to certain value z, right? Now there is a constraint part that they become z. I'm thinking more. Okay, what could be the z? Obviously the z will lie between the x minimum range, because the z minimum should be 0 and z max should be a0, because we concluded that the k value should be lying between 0 to a0. So obviously the z would also be lie between 0 to a0, because z is always lesser than k. Yeah, because our target value finally all array element will obtain is lesser than equal to k. Fine. That is not our problem. Okay. Problem is that I need to check with what? I need to check with what? So we'll try to think more. If I say that this is a z, okay, and I'm performing, let's say that, not this. Let's say that I'm saying that this is an array element, okay, e of I, and I'm performing, oh my gosh, I'm performing the certain operation, mod of x, yeah, certain operation, and I need to make it a value equal to z. So if the z is 0, then this value ai mod of x, I want to make it a 0. So probably the x would be your a of I. Safely, can I say that? Yes, that is fine. That is fine. Okay, fine. But if z is not 0, let's say the z is z, certain z, what can I be the x? And that is interesting. I don't know what could be the x here. So let's consider an example. Let's say that AI would be your, let's say AI is 5. All right. I don't know what the x is. I have to make it, I have to make the certain operation with z. I know the z is, let's say, 2. Okay, let's say the z is 2. So what I'm getting, how can I make 5 mod something is 2? 5 mod is our AI, 5 is our AI, Z is 2. I have to do the moduli X, I need to choose so that it is equal to, yeah, it not get hampered, like it will get the Z as 2. So can you observe that I need here 3? Exactly. And how it 3 could be met? Can you think it? It is 5 mod. Can I say that? Certainly like 5 minus 2. Um, yeah. So can I not here in general we get that the axis, your axis, nothing but the a of I uh, minus of z. Really, it is. It is. This is our x. This is our x. That's what we get. This is our possible x. Okay. So I got the expression of x here. And I want that this x should be always greater than equal to k. Isn't it? And what is the k here? K is the med. Med is representing the k. So I want this to be always greater than equal to med here. Right? Because med is the, I'm checking that whether this value med will be the possible k. Yeah. So what should be the check here? Okay. Now, since I know that the z could be 0, exactly. So, and z could be maximum is e0. This is the limitation. So, what I can think of is, let's try to set more. Okay. What could be our limitation is that I can choose the x ai minus z. I have finally this constraint. Like I am left out with this, that the condition should be ai minus z should greater than equal to mid need to satisfy, where z is lying between 0 to a0. Can I say that? Yeah. So I can think of as, if z is 0, minimum case, ai minus 0 should be greater than equal to mid, or I would say that ai should be greater than equal to mid. Or more importantly, since the array would be, all element will be same and the minimum value is a0, so if the a0 is greater than equal to mid, I can conclude that all the other elements should be greater than equal to mid because the array is sorted, as we already discussed. Now, for higher limit, if I check, then it will be ai minus a0 should be greater than equal to mid. And if I look at this bound, then I'm getting that a1 a1 is the minimum bound of this ai minus a0. A1 is the minimum one. Yeah, look at this. A1 minus a0 will be lesser than a2 minus a0. It is. A2 minus a0 will be lesser than a3 minus a0. It is. Because a3 will be greater than a2 will be greater than a1. So if a1 minus a0 will be greater than equal to mid, obviously all the values will be greater than equal to mid. Do I not get it or not? It is. So this is our another condition. So finally I'm left out with that in the check function I need to check this only. The two conditions. I just want to highlight it. This is the two conditions I am left out with, and this I need to check. Let's just do that. Yeah. A0 greater than equal to med and ai minus a0 is greater than equal to med. This is the two condition I'm left out with. If these two conditions satisfy, I will say that the mid will be the possible k. Alright. If this condition will not satisfy, if like, yeah, border condition not need to be satisfied. If any of the condition will satisfy, I will say that the mid will be possible key, because if this condition satisfy, it might possible that yeah, I can make the all the value element could be 0. So yeah, that is the one. If this and if this condition gets satisfied, fine, I can make the all the value to be a0. And yeah, basically this, right? And if it is like, if I need to make any value target lesser than this, so that would also be made. That's not a problem, because if a0 is greater, you can choose, like, if this condition, second condition gets satisfied, let's say, then if any value will be, any target value other will be lesser than a0, obviously, so obviously that would be going to be greater than equal to met. So ultimately we left out that I need to satisfy these two conditions. What we look for is that I need to satisfy these two conditions. Oh, it's big size, I don't want that. Okay, let's try to think more. Okay, I need to ultimately satisfy these two conditions. I'm still highlighting. So this is our condition need to satisfy in the check. So what we look for? Let's code. We already get what we wanted, and we already get the condition that require in the check. Okay, let's go. So same thing I've done here in my implementation, I will try to do again so that we can understand better. All right, let's not. Okay, all right, let's cut it down, and let's remove this one also. Okay, all right, so what is our input format? If you look for this, what is our input format? Okay, okay, so same thing I've done. Let's try to convert this one. Okay, let's try, yeah, here. So the input format is n, and we're taking the array as an input. So that's what we're taking. Here we have n, we are taking the input of n, and we're taking the array as input. So just take the input vector en. So we're taking the array as an input. Right. Now I'm sorting the array as I discussed. Sorting will be, that's not, oh sorry, I'm sorting the array. Yeah, I assume that array is sorted. So what could be the binary source length? Like I always say that the lower range will be, lower range of source space is 0, and the higher range, let's take a buffer of 1e9 plus 7. It will certainly work, that is not a work, like, yeah, 1e9 will be the upper range, but we'll checking little bit more, because if that will be worked, other will also work. Like if this range is there, if the answer will be lying between 0 and 1 and 9, obviously it will lie between 1 and 9 plus 7. So that is a 1. So while low is lesser than equal to high, basically in the mid is low plus high minus low by 2. Yeah, let's keep it as long now. Okay, now if look at this, if check, obviously we'll pass the array, and what else should I get? What should I get? What should I pass? Obviously I will, exactly, I don't know what should I will pass here. What should I pass? Ting ting ting. Let's write the check function. Okay, I just need to give the value. Okay, so obviously I need to pass the array. Let's just pass. Okay, and obviously pass it by reference, else you get daily, because of lot of copy get created here in this operation. Instead of O of log n, it will cost you like n basically not of O of log n, basically O of log of search space. That is the complexity here. So if I not pass the array by reference, it would be a problem. Like multiple copies get created. Yes. So it will something like O of n into source space. Source space is something like log of k. K will be lying between 0 to 1 in 9 plus 7, something like this. So it will be very slow operation, but although it will pass here because our n is 10 to the power 5. So overall it will come out like 10 is to the power 7, something like that. So we're not concerned of it, but still pass it here by reference for the safety. Okay, and I'm taking that. What could be the thing is that I'm giving the mid. Mid is the value I'm looking for. All right. So let's try to first check the function here, and then we'll try to do. So I got a condition here that for the check part, if I think it like I have a condition where I'm, yeah, here I am. I have a condition that I need to check E0 is greater than equal to med and AI minus I0 is greater than equal to med, isn't it? Exactly. That is the one we look for. Okay, so let's just complete like what I'm doing, guys. So I'm here to the condition like what I'm saying is that, well, I'm checking that whether the med is one of the possible. Okay, is med is one of the, oh sorry, why I make RAM, is med is one of the possible. Okay, that is the one we'll look for if it is this or not. So if I think it, uh, the condition is that if okay, let's use the flag one, f1 equal to 0 initially, means it is representing that the first condition gets satisfied, that we check. And let's take the f2 equal to 0. It will also check the second condition. For both the condition I have determined the flags, right? So what I'm looking for is that if a0 is greater than equal to mid, let's say the first condition gets satisfied, f1 is equal to 1. All right. Similarly, if your, let's say, a1 minus e0 is greater than equal to mid, the second condition gets satisfied, f2 is equal to 1. So what I'm looking for is that if any one condition satisfied, the mid is one of the possible k, isn't it? So if f1 is equal to 1, yeah, f2 is equal to 1, any of the condition gets satisfied, I just need to return true, else I will return false. That is the one. That is our check function. So that's what, look at what I'm doing, like put the mid here. Okay, if check a mid is true, then the mid is let's put the answer here. So since the I need to maximize the answer, isn't it? So I will choose the minimum answer. What could be the minimum answer? That could be 0. All right. So minimum answer will be 0 since I need to maximize. So here I will choose in the minimum answer. Now I will maximize it. So mid is one of the possible answer. Basically, answer is equal to mid. So since mid is one of the possible answer, like mid is one of the possible k, so it will be equal to mid as in general. Now the thing is that I need to maximize this answer again. So I will search for the higher mid. Yeah, I will search for the higher mid. So what I need to go? I need to go right in the binary search. Like I need to go right in the search space. Yeah. I need to go right in the search space. That's why I'll put the low is equal to mid plus 1 to move the right, right? Else, the condition would be that the answer would not be possible. Mid is not our possible answer. So I need to look for the lesser mid. Yeah. So the search space I will go left, and that's why high is equal to mid minus 1. Fine. And that's it. We got the answer here. That's it. Let's try to think. By taking time. Yeah, that's our possible answer. So this is our answer, right? So we're done with the C question. Moving on to the next question, guys. Okay, guys, starting with the fourth question. Here we go. So the question is Blackslex and Penguin civilization. And here the time limit as usual per test case is 2 seconds. So we can safely do 2 into 10 to the power 8 operation per second. Um, yeah, per second. So penguins are civilized creatures, okay, and that communicate using permutation. All right. So penguins are communicating using permutation means penguins behaving like mathematicians. Really? Wow. Blackslex, as a penguin researcher, must study their means of communication. All right, obviously Blackslex need to research about permutation because penguins are communicating by permutation, and penguin researcher being he needs to study the means of communication of penguins. Basically, Blackslex need to study permutation. All right. So for a given integer n, consider the permutation p of array, and that line have a values like this permutation p for a given integer n have values from 0, 1 to 2 to the power n minus 1. Okay, and whenever you check this value to the power n minus 1, what it is, if you observe that, then you realize that 2 to the power n have one set bit, but 2 to the power n minus 1 for a given n have how many set bits? N set bits. Can we say that? Exactly. And here given with that as of p is I equal to 0 to 2 to the power n minus 1 summation, and we're taking the and of it, p0, p and 1, p2, like permutation values, and we are taking where popcorn set is number of 1 bits, basically number of set bits in a given value. Here you can see in the 5 we have 2 set bits built in popcorn. As we know, it will count the number of set bit for a given value. So same thing here, pop count 5 give you 2, means number of set bit we are looking for. Okay, now and we are taking the and of all that what is given bitwise, and we are taking the values like bitwise, and we are taking that is the concern. Okay, a permutation is considered sacred if it maximizes the SP. All right, so I need to maximize this function. Okay, and I need to find the lexicographically minimal sacred permutation. Okay, so what it mean that if the two permutation are equal, basically contain the equal numbers, all the elements of permutations are equal, then the lexicographically minimal will be the one which is having, like, if you compare the starting values, then the one which have a lesser value at a certain position, then that one would be the lexicographically minimal. That is what I need to give. So I need to take in mind that I will always print the lexicographically minimal permutation. Okay, The first line, if you talk, this is just the definition as we talk, leave it as it is. I'm going to the input format, and this is the test case, all right. Each test case consists of a single integer n, and it is guaranteed the sum of 2n over all test case does not exist 2 to the power 16, all right. It is a very informative info that exactly that's not going to be. I don't know what use of it here. Maybe some use. I don't know. Um, yeah, some use. I don't know. I still not figure out what use of it like. So I need to output the 2 to the power n integer permutation, and as we discussed, it should be lexicographically minimal. Okay, exactly. So now look at this function sp. I need to minimize it. Basically, sorry, I need to maximize it. All right. So if you think this function, this is the pop count of it. Basically, if I try to explain you, let me explain you. Okay. Let's take. Sorry. Yeah. So what is saying that I am given a permutation here. Okay. Let's skip it here. All right. So let's try to think it that sp. Yeah, let's write it here as s. That is your p0. Okay. Can I say that p0? Let me check once again what is the function is. Yeah, sp is p0 p1, and we are taking, okay, and p0 is the pop count of that. Okay, thank you. So p0 and with p1 and so on till, and we'll look at it. We'll look for the 2 to the power n minus 1, I guess. Exactly, the last element is that offset to the power n. Oh my gosh, exactly minus 1. That is the one. Okay, now because total I have made sure that 2 to the power n elements is there. Is it that? Um, yeah, 2 to the power n elements starting from 0. 2 to the power n element is there in the permutation. Okay, fine. That is the 1 our concern is total 2 to the power n elements. So I need to take the pop count, basically number of set bit, and I need to maximize this as. So what can I think of? I need to maximize this as, and I am always taking the bitwise and, isn't it? Yes, I am always taking the bitwise and. So look at this, what will it does? Let's take an example that if we have a, let's say 3, okay, so what is its in binary representation of it? 1 1, exactly. And if we have 2, what is the binary representation of it? That is 1 0. So if you take the bitwise AND of it, what you get? I'm getting 1 0. I'm getting 2 here. Can you look at one thing that the number of set bits decreased, right? Exactly. So can I say that if the number of set bits decrease means pop count is decreased? Exactly. And if pop count is decreased, then can I say that the S will get decreased? Exactly. 1 second. Huh? Okay, fine. So what I'm saying that the S will be decreased, right? Yeah. So S has decreased. Now I'm looking for more like what? So what is the conclusion from here? I will always choose the S, means initially I will try to put that value which have maximum number of set bit. Okay, yeah, what I'm saying that I need to maximize the S, so I need the maximum number of set bits, right? So we'll always try to put that value initially which have maximum number of set bits. If you're not convinced, then I will again prove this. This is the one let's take this 3, right? Exactly. Let's try to do in different way. Let's 1 second. Let's just prove this. Okay. If you choose the value, let's say 1. Similarly, here in this case, what is the set bit of a 0, 1? Okay. Let's choose. I'm choosing the 2, right? What is the set bit? Oh my gosh. Let's try. Okay, 1 0. Okay, if you take the AND of it, what do you get? 0 0. Which value is better? Like, if you compare this, considering the arrays have only 1 2 3, if you compare both, look at this. Which is bigger? This one, right? That is what I conclude. I conclude that I will always choose that value which have maximum number of set bits. Okay, so it means that, as I discussed, this 2 to the power n minus 1 is a crazy number. It have a maximum number of set bit. So I will always start the first element will be always the permutation is E0 is your A0 in saying that permutation, that's always 2 to the power n minus 1. Do you get it? That is always because it has the maximum number of set bits. Fine. Now let's come to the part that I need to generate the other permutations. Okay. So how can I generate the other permutation, guys? That is the concept. Okay. So for that, what I can do is, let's try to think. Let's say, all right, let's put it here. Let's take a test case. Okay, we'll try to analyze because I need to generate the permutation, right? Let's say that n is equal to 4. Okay, I need to generate the permutation, all right? Remember that. And the first, I need to choose always the maximum number of set bits. So if the n is equal to 4, what could be the values I can take? From 1 to up to 50? Yeah, these are the values I need to generate in the permutation. Isn't it? Exactly. And the first value I know is at 15. The first value is 15. I already know that. Fine, that's that. Not a problem. Now, I need to look for the other values. Okay. So for a given instance, if I tell you, for a given instance, if you try to think, then we'll try to think for a given instance. Let's try to think. Okay. Let's say for ith bit, because look at the 15, it is like somewhere this 111. Yeah, it is. This isn't binary. Yeah, it is. Fine. So look what I can think of. Initially, I will keep this 15 exactly. Now, for the next one, I'm moving and I need to take the S. Basically, I need to maximize the S. Okay, I need to maximize the S. That is fine. But another condition is given that I need to take the lexicographically minimal permutation. It means that If I remove the first bit, obviously for moving 15 to other, I need to remove the first bit. Okay, you cannot remove the first bit. If you remove the first bit, this will not be occurring. Basically, what I'm thinking, let me tell you. Okay, this is 15, right? Yeah, I need to generate the other values 14, 12, 11, 10. Right, that is a concept. I'm thinking that let's keep this here. Yeah, what should I think of? I'm trying to tell you, I'm trying to explain what I'm trying to do is that this is the 15 exactly. This is the 15 I'm getting. Now, what should I do that I'm able to generate other two? Keeping the mind, the condition is that I need to maximize the S. So condition 1, I am writing here. Okay, condition 1 is this is the condition 1. We'll choose always. Oh my gosh, that's a bad. Uh, we'll choose always that number which costs maximum number of segments. On taking bitwise AND with previous number. Can I say that? Yeah, this is the condition 1. And condition 2 is that I just wrote here. Let's write the condition 2. Condition 2 is that we'll choose number such that permutation is lexicographically small. Can I say that? These are two conditions I have to think of. Okay, fine. Now let's try to observe. For a lexicographically smaller, I am thinking. Okay, so I have a 15, right? Let's try to observe the certain values here. What is 14? Like, what is 14? If you try to think in binary, the 14 would be what? What is it? This 12? Yes. What is 13, guys? That is 1 1. Yes. 12 1 1 0 0. 11 1 0 is yes. What is 10? 1 0 1 0. What is 9? Can you think of? 1 0 0 1. So I just wrote this number to do certain analysis that I cannot need to make this bit 0 again anyway. Alright, I don't. Yeah, because making this 0 will not work. I can make this bit 0. Alright. And the thing is that I cannot make this bit 0. If you make this bit 0, right? Let's say, yeah, I'm concerned with this. This is the 1 and this is the 1. What bit I make? Because I need the S to max. This is a little bit challenging. Let's try to think more. I need to make the s should be max. So what I can think of, I cannot make this with 0. Yes, but I can make this with 0. If you make this with 0, these two bits will always be secured. Can I say that? Exactly. These two bits will always be secured. So I always left out with 1 1. Exactly. And this position I'm making it a 0. So I can do the changes at this position. And I can generate the values like 11 and something like that. Can I say that? Exactly. So what could be the possible values I can generate from this? If you try to observe, that is maximum I can generate is 1011. And this number is nothing but 1 second. Put it there. And let's little bit small at case. Exactly. So this number in decimal is nothing but what? 11, isn't it? And what is the difference from the this number? What is the difference from this number? Can you see that? What are you trying to say? Um, okay, I'm not concerned about this. Let's leave this. Let's leave this for a while. Let's try to think more. Okay, so I'm thinking now I make this, I able to generate only one number. Fine. If I make this with 0, if I make this with 0, what could I left out with? Let's try to think. I am okay, so I'm making this with 0, right? Exactly. Now, this number is fixed. This is fixed. So these two bits are fixed, right? Exactly. And I'm left out with these two positions. Basically, I'm left out with these two positions. Can I say that? Exactly. Two positions. Yeah. Exactly. Most importantly, yeah, these two positions I need to fill. So what can I fill? Like, so if you try to observe, this is clever observation, okay? There could be filling like 0101. Exactly. There could be filling like 1001. If the next set of value if I fill, okay? And there could be 1 second now. Very nice pattern you get as I observed. I went to show it 1 second now. Okay, guys. Yeah. All right. Let's. Yeah. 1101. So I want to show you how beautiful pattern I'm getting. Okay. So if you try to think what value it is, what value it is. Okay. Let's try to think. Apart from this, we're not going to get any pattern. No, we're not going to get any pattern because this is the maximum number of filling I can touch. Up to 15. Yeah. So this value, if you try to think, what is this? It's 3, right? Exactly. What is this, guys? Try to think again. It is 5, right? Exactly. Oh, sorry. Is it 5? No, right? Really? Are you sure? am guessing it is 9. Exactly. And what is this value? 13. So you are done wrong here. It is 5. Exactly. I'm just checking how much conscious you are. Okay. So it is 5, it is 9, and it is 13. Cool. Now, I want to show you how beautiful pattern you can get. Look at this value, okay? What is this value? 0, 1. I'm not going to change this, right? But what is the difference, guys? Look at the difference. Let me show. The difference here is a 4. The difference here is also 4. Right. Okay. And these 2 bits is unchanged. Can you see that? Yeah. So at the bit position 2, like what is the bit position here? This is the bit position 1. So from the bit position I plus 1, we start adding the element. Can you see that? Yeah. So that is a 1. And same thing if I try to show you, that's what I am trying to show. If the same thing, if I try to show here, okay, let's do once. 0, 1, 1, right, guys? Oh, 1 second. Huh? Oh my gosh, my highlighter is not at work. Okay, 0, 1, 1. I am adding at bit position 3, isn't it? Yeah. Up to bit position 2, our value is fixed. And this value, if you try, let me try. Okay, you will get this is the one. Okay, look at this. This value is, if I try to say how much this value initially is. 1 second now. This value initially is 3. This value initially is, okay, I will try to put, yeah, it is fine. Let's take another, just taking here and later I put this value initially is 1. Basically, I'm concerned of putting this value. This is 1. So observe, this value become 11, isn't it? So how much we have add here, just like this, 8. So what is the coolest observation here is that the 3 bits are fixed, exactly. So if I adding at the 3rd bit position, for to get the next number lexicographically smallest, I need to add 2 to the power 3. Okay, for the if the 2-bit position I decided that this would not going to change unchanged like 2 bits. So up to bit position 1 we are filling from the bit position 2. So I need to add to get the next lexicographically number nothing but what guys, 4, basically 2 to the power 2. And this is the beauty of this question, I would say. That in general, if I try to conclude, then let's do the conclusion. If you fixed, let's say for a certain bit position, if you fixed that this is the 0, I want to making this bit the ith bit 0 and the other one is remain unchanged, other one have 1 means other one have all the bits set. Then if this is the ith one, then to get the next lexicographically, yeah, if this is the ith bit and you know that the bit position is, this is the bit position 0, this is the bit position 1, this is the bit position 2, this is the bit position 3, this is the bit position 4. So to get the other permutation values, I just need to have add 2 to the power 5. Yes, here. Basically, I need to add 2 to the power 5 here. So for a ith position, to get the next lexicographically value, you just need to add 2 to the power what? I plus 1. Considering that where ith position we are making 0. Ith position we are unsetting it. Okay. Ith position we are unsetting it. Can I say that? Exactly. That's what it does. This is the question, huh? Basically, so it means that if I am given with a certain permutation, so in general what I do is that, let's say that I'm given with this n equal to 4 only. I will first, I know the maximum value is 15, 1, 1, 1. Now, I will, 1 second now. Why bit problem it is. Okay. I have decided the force value is 15 obviously. Now, in this group, there is no change, right? Now, I will easily seek for this one. And for this group, I'm getting certain numbers. And what number I get? I just get that, what it is, 11. Similarly, now I will look for, okay, let me move up. All right. Okay. Hmm. Similarly, I will look for the other one. And this group, we have making 0. And from this, I'm getting numbers like, yeah, obviously you are unchanged. So this is the 3 initially. If you don't fill any. Basically, if you fill 0 here, 3 you get. Exactly. For this group, I will make the numbers like, what do you say? Initially, I have 1, then 5, then 9, then 13. Okay. Similarly, what I'm looking for is this. And we'll generate basically 0. Yeah, here. And in this, I will able to generate all the values. And that would be the lexicographically smallest one. And this is the pattern here. So what we are waiting for? Let's go to code, right? Yeah. So this is the implementation I have done. Let's try to redo for you. Like, okay. Question is just telling that take the input as n and generate the other value. Okay. So I'm taking a container vector A that will store the permutation. So what is the first value as we say? That is 2 to the power n minus 1. So how can you generate 2 to the power n minus 1? Now, there is a catch. If you use the power function, we know that the power have a floating point error, isn't it? Exactly. Power function will consist of floating point error, so I will not use power function here. Instead, I can use the binary exponentiation to get the exponentiation, but since it is the binary function, power generation of 2, we know we don't prefer to use the long binary to generate the power of 2, we will use the faster bitwise operation. Can we say that? Exactly. So we'll do the faster bitwise operation here. Let's go for it. So I need to generate for 2 to the power n minus 1. So I will shift 1, left shift, and it will give you 2 to the power n minus 1. We'll get the 2 to the power n minus 1. This is the maximum value. Let's put it in the container as the first value. Fine. Now, I know that the maximum limit value could be what? 2 to the power n? Exactly, I can check. Like, no value greater than this can exist, isn't it? Exactly. Now, we are moving on. We are saying that what I decide, I will make the MS base, basically most significant base bits. I am making it as 0. Can I say that? I'm making the most significant bits 0. So we're starting from back. Indeed, to make the performance, like basically to get the power of 2 to the power n, I need a bigger power, right? Exactly. I need a bigger power of 2 to the power n. That's why I'm shifting like this. So what I look for is I'm starting with the back because 2 to the power n already achieved, isn't it? I look for 2 to the power n minus 1. So we'll start with n minus 1 and we'll try to generate all the possible powers. Okay. And we'll try to decrement it. So what is the starting value for the AP? Yeah, we're looking for AP. What is the starting value? What do you say? Um, I don't know, like 1. Right, so say exactly minus of. Sorry, it's not right set. Oh my god, what I'm looking, yeah, bro. The generation of power of 2, I'll use left set, obviously. That's what I use. So this is 2 to the power, say, minus 1 in general. Okay. And what is the common difference in the AP to the power I plus 1? So basically here I have used the I as Z. So let's take it as I only. It's a bit confusing. Okay, let's do this. Exactly. So let's take the common difference as 2 to the power I plus 1. So to make this common difference as 2 to the power I, the first term always is 2 to the power I minus 1. We checked, right? Yeah, because, yeah, correct there. Do you get or not, my dear? The first term always is, yeah, yeah, that is the one. Because look, if I try to get this 0, 1, 1, I'm making this, right? This position, this bit, yeah, this bit I'm making the 0, unsetting this bit. So this positions, what is this? If I'm unsetting the third bit, this value is what? 7, right? So 2 to the power 3 minus 1. Yeah, that's what it is. Do you get it? Thank you. What is the common difference, guys? 2 to the power I plus 1. So that's it is 1 right shift. Left shift. Not right shift. Left shift. I plus 1. Okay. And I need to just generate the other values. So we'll take j equal to start. We're starting it. And j is lesser than maximum limit and j is plus equal to common difference, and I just need to do the pushback in the container to do the values, right? So if I just debug it to more clear to check there is any error or not. So I say I don't have any error, okay? J is not declared. I am idiot. Yeah, getting the same answer. So let's just print it out using the range based for loop. Okay, there we go. Thank you. That is the simple answer of this crazy question. Isn't that? Let's move to the next question, and that is the last one I have solved. And the first time I have solved E of any CF contest. So here we are, guys. Um, where I am, like here only. Okay. Moving to the last question, guys. Okay. Okay, guys. Starting with the fifth question. Here we go. The question is Blackslex and girls, and here the time limit per test case is 2 seconds. So as we know, we can perform 2 into 10 to the power 8 operations. Okay? Yeah. No, per second, obviously. Moving on to the question part. After failing to pick up a girl, hmm, careless person, isn't it? Not even able to pick up a girl. Wow. Using the version sequence of fixed length string, Blackslex has turned his attention toward politics. Oh, it usually happens. If some girl will, hmm, the person will go toward politics. Okay. Due to his high charisma, he is now in charge of drawing borders for n voting district in his country. Okay, high power have given to him. Like he is the in charge of drawing border of voting district of his country. Okay, and in blacks like country, there are X voter for party A and Y voter for party B. Okay, so maximum we have only two parties. Somewhere like a communist one, isn't it? Not like India where we have like plenties of parties, isn't it? Yeah. So using his amazing drawing skill, he can allocate voter from any party into any district of his choice. Oh my gosh. The person have skills also, and he not able to pick up a girl, and he have a drawing skill and not able to pick up a girl, and he is a manipulator. Oh wow, good person he is. His history with the bit string has led him to wonder if he can allocate voters such that winner of each district will follow a certain bit string pattern. Alright? And to avoid suspicion, he must allocate at least PI voters into each district. Tell him if it is possible. Okay? So if I talk about formally, I'm given a binary string S of length n and the array P of length n, alright, and the two integers x and y. I want to determine whether there exist two arrays of non-negative integers a and b of length n that satisfy this condition. A1 plus A2 plus AN is equal to X and X voter for party A. So this is basically the count of voters of X, basically count of voters for party A, and that is coming out is equal to X. Count of voters for party B, that is coming out is equal to Y. And for every I belong to 1 to n, count of voters for party A plus count of voters for party B is greater than equal to the voters assigned to the district, isn't it? And if the binary string says 0, means AI is greater than equal to BI, means count of voters for party A is greater than count of voters for party B, means A will win. If Si is equal to 1, then Bi is greater than equal to Ai. It means that count of voters for party B is greater than count of voters for party A. It means that B will going to win, party B will going to win. Yeah, and this is the input format that we're given with, right? And this is the binary string as second line, third line is the exactly P basically minimum voters assigned to district. Okay, I have to output that if there exists an array A and B. Oh, I don't need to find the array at least. I have to only tell if A and B is possible to exist or not. Else, if A and B will exist, I will simply say yes. If it's not exist, I will say no. And remember, this is a case sensitive one. So in the most CF question, we have habitual like they doesn't case the like they will take this is mixed case. You will print it as even like this is a complete uppercase, right? You can even print it as mixed case. You can even print it as lowercase. They will accept it. But here they deliberately mention that it's case sensitive. So keep in mind, you should not put like you should must print this, not any lowercase. So that is a safety part. Now let's come to the logic part. What I can think of here is, let's go. Let me try to explain you. Okay. Let's take this. All right. Okay. So what I am given with here. One second. I am given with what? There is X is given, that is total uh, voters of party A. Can I say that? Y is given, that is total voters of party B, and I will say that the vector P is given, and if you take that, if you yeah, the vector P will representing the minimum voters required in each district. So P of I is minimum voters assigned to each district. Okay, and clearly there's a one condition we raised that if all if you find the sum of all P, okay, like if you find the all P, if it is greater than X plus Y, the total voter. So minimum voter assigned to each district sum is we are getting more. Okay, so if this is the case, obviously this would not be possible. So this is one of the impossible case we can get. Can I say that? Because I'm getting the minimum voters assigned sum is more than the total voters. So obviously it's not possible one, isn't it? Okay. Let's try to think of the cases where it is possible. So, okay. So we'll try to see, we'll try to simulate. Okay. Let's think of the other cases. All right. So let's try to think what could be the other cases. Okay. So there is a one case possible that there are total n districts, right? In all the n district, the string is 1. Okay, all right. So if string is 1, basically means that only party B wins, isn't it? Yeah, only party B wins, isn't it, guys? If only party B wins, okay, then what could be the minimum margin that party B have? Like, can you say that? Yeah. If, let's say, in a certain district, minimum voters is equal to P of I, right, assigned. So for any party to win, considering the minimum voter case, it should must have a vote P of I by 2 plus 1. It win by 1 margin, right? Yeah. Let's say in a district, I have total 100 voters. Then for any party to win, one party should have like 51 voters, others should be 49, isn't it? Exactly. So that's what I'm taking, that if this is the case, if any party will win, then P of I by 2 plus 1 will be the possible case. For, like, basically, if you have to win over a district, then yeah, this is the amount of voters you need in your party over district. Okay, this is fine, but what could be the conclusion from it? Right. Um, I get it, but let's try to think more. Like, this is the case, okay? So basically, if, like, yeah, it would work. That is the one thing. Similarly, you can do for 0, 0. Let's try to be more precise, okay? This thing would work, but let's try to be more general, okay? This would work, but it's somewhere lagging, right? We'll try to think of more general situation. Okay, now let's take this. Okay, so let's say for any district, um, what should I have? Like, mm, let's say you have a certain voters for party A and certain voters for party B. Okay, then can I say that the let's say the certain voters is PA for party A and PB for party B. Then, and I'm saying that party A would be going to win. So PA minus PB should at least greater than equal to 1, isn't it? In a district, if I have PA voters for party A and PB voters for party B, then PA minus PB should greater than 1 for party A to win, isn't it? Exactly. And if I have total n districts, can I say that? I have total n districts, right? And in all the districts, if I if only A wins up to n districts, then can I not say that PA minus PB should be overall, yeah, plus overall PB should be greater than or equal to 1 into n. Can I say that? Basically, I would say let's little bit resize it. 1 second. What I'm trying to say. Okay. So basically, what I'm trying to say that overall PA would be what? X, the total A, yeah, minus Y should be lesser than or equal to n. Isn't it? Yeah, that is a condition for um, all the district if E will win. So if all the district A will win, our string have 0, 0, 0, something like this. 0, 0, 0. Yeah, all the district of our A wins. And if I like, what should I do? If I apply the same thing over B, then there I get, if I have like B uh, over all the districts, for all the n districts, then the condition I get is again like overall PB minus overall PA should be greater than or equal to n, isn't it? Y minus X should be greater than or equal to n. That is the condition needed, right? Exactly. For all A to win and for all B to win. Okay. Now, if you look at more cleverly, then you realize that this is nothing but minus of x minus y greater than or equal to n. So I'm thinking that, let's say, what should I'm thinking? Okay, this is x minus y. Uh, let's use some different color. What I am thinking, I'm telling you so. So this is x minus y, right? This is minus of x minus y. This thing is clear, right? That for any party to win, uh, it requires like p of I minus, yeah. This is a much general case. This is the one we look for. Say minimum vote is pi, so any party to win, the vote should be pi by 2 plus 1. Exactly. And if overall A wins, then x minus y should be greater than or equal to n. This is the another condition. So this is the case, I would say, perfectly fine if yeah, if only one party is winning, isn't it? Yeah, moreover fine. That's not a problem. But what if both the parties are winning? Yeah. What if your string is something like this? 1 0 1 0 1 1 0 0. Mixed case means in all the n districts, some district the evens, in some district the b wins, and I am given a minimum amount of vote, right? Exactly. Now the point is that what could I conclude? What could I conclude? Look, this is very simple, right? If only b wins, we conclude that it require at least pi by 2 plus 1 votes in each district to win, and provided it will satisfy this condition, minus of x minus y should be greater than equal to n, then I would say that, safely say that, yeah, the b will wins, isn't it? Exactly. Similarly, for all the statistics, if I have a, then this condition will must be satisfied, and apart from this condition will be satisfied. We'll safely say that e will wins. But what about this mix case? Like, I'm a bit clever here. What it is? 1 0 0 1 1 0 0. Okay, and it satisfies the case that x plus y is actually greater than p of I. Okay, so I have to think of distribution here. Okay, now what should you do? That is a point. That is a twist. What should you do? If I try to prove this, then you realize that actually you don't need to do anything. Why? Why I don't need to do anything here? Because there is a minimum amount of voters is given. Can I say that? Exactly. The minimum amount of voters is given, and there is a maximum amount of voters is given. So look at this. I'm trying to clarify that. Total voters I have is x plus y. Exactly. And total minimum voters I have is, um what should I think of, like sum of all p. Exactly, sum of all p, that is the total voters, total minimum voters. Okay, now what should I think, what could be the distribution? Let's say it's demand something, right? For a certain party to win, I know that it requires the pi by 2 plus 1. Okay, so if that party have certain extra voters, can I not allocate those to anyone in the win case? Exactly. And in others, I will safely make it as pi by 2 plus 1. Similarly, in the y case, let's say if b wins in some case, whatever will be the extra apart from pi by 2, I will allocate in that case. In other case, I will put pi by 2 plus 1 if any win will be there. And then safely I can say that this case will always be tackled. So that's why I can say that both array X, basically array A and B, will exist in this case. Do you get that or not? That is a point, like. So basically I have overall only two cases. In the one case, like only one party wins. Okay. And in that we have two sub cases here, like only A wins or only B wins. And the other case we have is that both wins. And we concluded that if x plus y is greater than sum of all p, then this case would always be possible. So what are we waiting for? Let's go to code, right? Let's go. So this is my implementation in the contest. We'll try to implement here. Okay, let's go. All right. Okay. So initially I'm given with n x y. So we'll taking this the input here. All right. Okay. Now we're given with the string s. So I will take the string in the vector of character. I usually prefer to not use string. Instead of this, I use mostly DQ, like, because DQ done my work. Like, it will do the push back, it will do the pop back, it will do the push front, it will do the pop front in the O of 1 only. So basically it worked. Like, I don't need to use string in any way. So I prefer to DQ, but if sometime needed, I use string. But here I don't need to do like pop front and push front. So I'm simply using the vector of character. And yeah, that's why I'm using the vector of character here. So let's just input that. Okay. Now I have the array P. So let's just take that input of it. Okay. So here we have array P. Moving on. Now I want to find the first case is that the x plus y should be what? Always greater than sum of all p. So let's find the sum of all p. And if this x plus y hour is lesser than sum of all p, that is the minimum one, we'll simply say the answer is no. And let me check like whether my macros have no or not. Like yeah, it has, so that will not cause the problem. Okay. Else come to the other part. So what could be the other part where the answer will exist? Actually, x plus y is greater than or equal to some. Okay, so I'm using the flag a, okay, is equal to 0. Basically, the flag I'm using, it will keep whether the string like whether the string contain any character, or basically any character that is 0. It means that any character where a is going to win. Okay, if the question says that only, let me recheck that whether I'm going right or not. I'm considering the 0 means a wins. So here we have like where it was like, yeah, s of I 0 ai, yeah, fine. S of I is equal to 0, ai is greater than bi, so a will going to win. Fine, that's the one way I'm considering. Okay, so that's what I'm telling, that flag A will check whether any character is there that will contains the winning of a or not. Then flag B is equal to 0, it will check whether any character is there that in the string that is one, that ensure that uh, we have one district where B is winning. Okay, and we'll have the count of votes of A, count of votes of A, and let's say the count of votes of B is equal to 0. That's basically we are considering the minimum case. Okay, that minimum we require this much count of votes. Okay, yeah. Now come to the more part, like what I say. I will just what should I say? Like we'll just do. We'll just iterate over the string. So that's what I'm doing. And if I saying that if s of I is equal to 1, basically character 1, we'll make the flag of B. Oh my god, what I'm doing. Flag of B is equal to 1. Okay. And basically, if s of I is 1, means in this district the B is winning. So the minimum vote required for B to win, as we conclude, that will be Pi by 2 plus 1. Can I say that? Oh my gosh. Yeah. Else, basically we have s of I is equal to 0. So yeah, the E is winning. Can I say that? So flag is setting 1, then this is stick the 1, A is winning, and minimum vote required for A to win obviously would be your P of I by 2 plus 1, considering this. Okay, exactly. And if there is any extra voters, we'll simply give it. Okay, that's really not a problem. Okay, now this is the one part. Now we are considering the cases where only, let's say, 1 1 1, something like this. Basically only B is winning. Okay, so if only B is winning, what should I think of? As I already told you, if only B is winning, or like only E is winning, okay, it means that neither flag of A, yeah. So better it is that let's try to think more. I'm saying that only A is winning or only B is winning. So if only, let's consider the first case. Let's forget for a while. Let's consider the first case. Only B is winning. So if only B is winning, the flag of A definitely should be 0. Yeah, it have not changed. It have not encountered 1. This block have never operated. So that's why the flag of E should be 0. And we'll look for more. A flag of B is obviously become 1, isn't it? So that is the one we look for. Flag of B is 1. Okay. In this case, I already told you that B is winning. So overall count should be y minus x should be need to be greater than equal to n, isn't it? So from here what I can conclude is that y should be greater than equal to n plus x, isn't it? So yeah, for this case to occur, for this case to possible. And the second condition is that apart from this condition, for all the B to win, apart from this, I told that the count of B should be um what should I say, like count of B, basically Like this is the minimum vote count of B, isn't it? Yeah. So this should be must be lesser than or equal to Y. Because if minimum amount will be more, then we cannot say that the win occurs, isn't it? So that is the first thing. So what should I say that if count of B is greater than Y, we'll safely say no, it's not possible because minimum amount of vote you need for B to win is greater than that. So it will not possible case. That's the first thing. Okay. Yeah. That is the one we look for. Else, and I will say that it is in general also possible, right? So why should I writing here? Let's write it globally, right? Not globally actually here in outside. Because in the mixed case also, if the count of B is greater than Y, then that case will not exist. So that's what I'm telling. If your count of B is greater than Y, or even for x1, like count of A is greater than X, means so what I'm telling that if minimum amount of voters is needed for B is greater than total voters of B and minimum amount of voters needed for A is greater than total voters of A, obviously this case would not be possible, isn't it? That's why no. Else, we'll try to put it here because minimum amount of voters we ensure that is, yeah, that is lesser. So we are here at this case, and that's why I am considering that now safely that x will be always greater than equal to count of A and y will be always greater than equal to count of B. So I'm not need to bothering about this case. I need to bother about this. That now if only B is winning, then this condition should must be satisfied exactly as we have proved. So if this condition is satisfied, then the B will wins. If it's not satisfied, then the B will not wins. So if Y is lesser than n plus x, we'll safely say no, else we'll safely say yes. Similarly, if what do you say like okay, 1 second, yeah, if flag of A is equal to 1 and flag of B is equal to 0 means all the cases we have like this 0 0 0 means only A is winning. So here also I would say that I need, as we discussed, x minus y should must be greater than equal to n. Can I say that? So can I say that here x is greater than or equal to n plus y? And obviously the count of A, minimum voters, is lesser than equal to x, so that is not our problem. That's why here if your x is lesser than n plus y, will not have the voters possible, isn't it? Else it does. Okay, and if I talk about the mixed case, then there is always possibility as we already proved, and that is our answer here. Let's try to run it. Oh, there is something I missed. What is this case? Oh, basically in the macros I don't have this p. I just need to pass this like Yes, yeah, that's the one. That's the one. That's the answer. And this marks our discussion. Okay? Very nice. Let's go and tell. Okay.